So
You are confusing us.
do we need graph paper?
With your ways.
Yeah.
Yes, you will need graph paper. We are finishing the chapter today with the last thing. So we did cut short our conic section chapter. We didn't do well. Mainly what I want you to be able to do, so you do have a test on Wednesday, is graph these. Okay, that is by far the most important thing that I want you to get from this chapter. So we are doing the last part, which is hyperbolas. Hyperbolas are going to graph a little bit weird, but their formula is very similar to an ellipse. So we have x minus, why does it do this to me? X minus a squared over a squared minus, instead of a plus, so that's going to be important, work. I'm getting angry.
Kind of like it's an actual ink pen where you rub it over to make the ink start running.
Yeah, it's actually like simulating the frustration of a pen that's dying. Alright, so minus k squared.
Is it your computer or that thing?
I think it's actually my computer needs a helmet. That's the thing. There's actually going to be two formulas for this, so I'm going to write the other one down. They are very similar. Okay, so we have, because we have a minus sign, we do need to account for which way, which order is in. Because this is actually, with an ellipse, the number that was bigger determined which way the ellipse opened. But for hyperbolas, the thing that is positive is the way it opens. So it opens in the direction of the positive term. Now, in either of these cases, my center is HK, okay? And now we don't use the same terminology. We don't have a major and minor axis. We have a transverse axis. And we have the conjugate axis. And the transverse axis is the way it's opening. The conjugate axis is the other one. So, like with ellipses, I think the best way to learn this is to go ahead and start graphing them. Now, there's some other pieces to the puzzle that we're going to have to add into here. So, we'll get to that. So, let's graph one. So, let's graph, I'll put it right here just so it's, let's graph x plus 1 squared over 4 minus y minus 3 squared over 1 equals 1. Okay, so this one opens along x, so it opens left and right. Okay, now like with ellipses, I'm going to square root whatever's below these. Okay, so along x, I'm going to have a 2. And along y, the square root of 1, I'm going to have 1. You with me there? Okay, so I'm going to plot my center, -1, 3. So here's my center. You with me on how I got my center? Okay, now I'm going to count along x 2 units. Now I'm going to count left and right 2 units, just like an ellipse. And then along y, I'm going to count up and down like an ellipse. So do you see where I got those 4 points? Now, here's where it's different. You can think of a hyperbola as an ellipse folded inside out, like if it were splayed open. Okay? So we are going to actually connect these and form a box. And wherever those meet, I'll do it in blue, so they meet at these points. What I'm going to do is through the center, I'm going to draw a dotted line like this. And I'll do it both ways. And you can kind of think of this as drawing a slope. So I'm going to draw a dotted line. And then this is why we answer which way it opens. So either my graph is going to go up and down like this, or it's going to go left and right like this. So since it goes left and right, this is a vertex. So we do have that terminology. We still have vertices. And then it opens like this, and it gets really close to those dotted lines that I drew, but it does not cross those dotted lines. But it gets close. And that is my hyperbola in green. Now I'll do another one.
Can we go back to
So the answer is green, not
Yes,
the other stuff.
right. All the other stuff is what I use to actually draw that. So it's a little bit more in depth than the ellipse. I'm going to graph one more, and then we're going to go on to the different types of questions I might ask you about this. And since we do have to have our test on Wednesday, I don't want to leave it till after the little trip. I want us to just clean slate after our vacation, so we don't have to worry about that. Let's go on. So I'm going to go ahead and erase this. We'll try another one. Gosh, I'm on my phone. All right. So what is my center? Now be careful. Nope. -3, 2. The order has changed. Are you with me? The y component is still with y. The x component is still with x. All right, so there's my center. -3, 2. Now, along x, so which way does this open? Well, this one opens up and down. Why? Because y is the positive term. So it opens up and down. Along x, how much am I going to count? 3. And along y, I'm going to count 1. Okay, do you see where I got that? And then I'm going to go ahead and I'm
Did
going...
you graph it wrong?
Huh?
Isn't it, you said it was -3, 2.
Ah! You are correct. Good job. Let me move you. There it is. All right. Good job. Good catch. Oh. All right. So now I formed this box just like I did before. Okay, so I'm going to go, and you see how as I go left to right, I go up 1, right 3, up 1, right 3, up 1, right 3. And going the other way, down 1, right 3, down 1, right 3, down 1, right 3. Okay, so those, that gives me this dotted line. Now this one opens up and down. Now this time I'll draw it in red. So that means this is a vertex. And now my graph opens really fat. Okay, I messed up that left-hand side. But see, it gets really close to those dotted lines. let's do one more. One more of these, and then we're going to get the other things that we need to write down. All right. Let's try. So this one opens which way? Well, first, what's my center? What's my center? -1, -2. And this one opens which way? Left, right. Why? Because this is the positive term. So -1, -2, it's right there. I'm going to count how much along x? 2. And how much along y?
5.
Okay, and then I draw my box. Now,
Right.
okay, hold on a second. Now, hopefully you're understanding where I get this box. You can do an ellipse the same way. You could draw this same box, but your goat would connect on the inside. Okay? But here, we are going to draw our asymptotes. I'll draw them with my line tool this time. So some of this is going to be cut off, but you get the point, I hope. And then to actually graph it, so I'll do it in green. Okay? Any questions on how to do that? Now, don't make the mistake of opening it the wrong way. Sometimes you get in the habit of just doing it all the same way, and you don't pay attention whether it should open up or down. And if these are in a different order, there will be some problems. Okay, at this point, what we're going to do is we're going to take a look at some questions that we might want to answer relating to these. So any questions before I get to that on actually graphing them?
Aren't those up and down?
It would not be up and down. With a hyperbola, it's all determined by it opens in the direction of the positive term. Okay? It does not matter in the case of the hyperbola. See, if this were an ellipse, let's say this were a plus, it would open up and down because the 25 is bigger than the 24. But for a hyperbola, that does not matter. What matters is which term is positive. That's the positive term, so that's the way it opens. You with me on that? So there's a difference there. Okay, so for a hyperbola, we want to know the location of the vertices, the foci, the equation of the asymptotes. Those were those dotted lines that I was drawing. And maybe, if we get to it, the equation of the transverse and conjugate axes. Now those are actually easy to get. If you know the center and the way it opens, those are easy to get. In fact, let's go ahead and start with those. Okay? So let's do this example. Alright, so in order to get all of these, I need to know my center. So what is the center of this hyperbola? -2, 3. That's my center. Okay, now, I'm going to note this opens which way? Left and right, because x is the positive term. I'm going to count along x. How much? 5. And I would count along y. How much? 2. Now, like with a hyperbola, my foci are always on the transverse axis. Which I suppose we should draw this out and see where the transverse axis is. You could think of it as kind of like the major axis, but it's not always the longest thing. It could be shorter, which is why we don't call it the major thing. The vertices are always on the transverse axis. And that's another way of thinking the way it opens. Okay, so the transverse axis is the way it opens. So the transverse axis, in this case, is going to be, it opens left and right, so that's going to be y equals 3. The equation of the conjugate is going to be x equals -2. So it's kind of like the opposite of the way it opens, like is y equals 3. Because here's going to be our diagram. Let's get a diagram done. So I'm going to draw a hyperbola here. I'm not going to put any axes on it or anything. I'm just going to say, okay, here's my hyperbola. Here's my center. Okay, and then we're going to do like we did with the ellipse, where we label all the parts. Okay, so this right here, okay, that is my transverse axis. And this right here, that's my conjugate axis. In green, right here, those are my what? What are these?
Vertices.
Those are my vertices. So we still have vertices. Okay? And then, I'll put them in yellow, hopefully it shows up. What are those, do you think? Those are the asymptotes. Okay? So in yellow we have our, these are my asymptotes. Alright? And then I need to know where my foci are. So I'll put those in green. My foci are actually outside. So these are my foci. They're longer than the vertices. They're further out in the case of the hyperbola. These are my foci. Okay, I'll give you a second to get that diagram down. So those are all the parts that we're talking about.
Go back some.
Hmm?
Can you go back some?
Mm-hmm. Yeah, actually we did not finish this up anyway. Alright, so we have our transverse axis, because this open left and right, is y equals 3. And if you're in doubt on any of this, even if you're not asked to draw it, just draw it out, and sometimes that helps to get the things you're asked for. Alright, the vertices. So our vertices are going to be, since it opens left and right, I start at my -2, and it's going to be plus or minus, I count along x 5 units. And this should be a 3 here. Which gives me vertices of negative 7, 3, and I actually should add these out, so don't be not adding them out. Don't be lazy. If you can add it, you add it. Alright, now I'm going to grab this equation to finish answering questions so that we can oops. I wanted to copy that, not paste some URL. No, don't delete it. Copy. Okay. Other class. Okay, let's paste. Maybe this is, whenever your stupid mouse goes away, it is a pain in the butt. Forget it. Okay, that's our equation right there. Alright, so our center once again was negative 2, 3. We have answered where the vertices are. Now we're going to answer, well, what about the asymptotes? The easiest way to do the asymptotes is with point-slope form. That is by far the easiest way. So y minus y1 equals m x minus x1. Well, we know y1 and x1. We know them because our asymptotes always go through the center. So this is the center. This is my hk. So it's going to be y minus 3 equals m x plus 2. But the question is, well, what is my slope? Now, I hope you do better at remembering this than the seniors did. Okay? Our slope for our asymptotes is always the square root of whatever is under y, no matter where it is in my formula, whatever is under y, the square root of that, over the square root of whatever is under x. And why would that be the case? Because slope is change in y over change in x. So I don't care that the order of this equation might be different. I don't care which number is bigger. I'm counting along y with the thing under y, and I'm counting along x with the thing that is under x. So in this case, my slope is going to be 2/5. Okay? Now when I do a square root, I have plus or minus. I have one of mine go up and one of them go down. So that gives me my hyperbola's asymptotes. You with me on that? That leaves one more thing to find with this. Then we'll do one more where we find all this stuff, graph it, and then we need to practice, practice, practice. So we need to be able to do ellipses, hyperbolas, and circles. Probably not going to spend much time reviewing circles because I think you guys pretty much nailed that. We don't need to spend extra time on it.
Go back. I didn't.
Okay. So if you want, you could say our slope is the square root of a squared all over the square root of b squared. Because I'm using a to mean whatever is under x. Oh gosh, I'm dumb. Why'd you let me write that? That's wrong. It's b squared over square root of a squared. So m equals b over a. Because I am using b to mean whatever is under y and a to mean whatever is under x.
Can I shorten?
Okay. Alright, so now we're on the foci of the same equation. Here is a new focal length formula. It's a little bit different than for an ellipse. So for an ellipse, the foci were inside. That meant A was the longer length. So our focal length formula for a hyperbola is, instead of subtracting these, we add these. So it's basically directly Pythagoras here. So let's compare. Well, not yet. So let's find our foci. So C is, in this case, going to equal square root of 25 plus 4. So C is square root 29. Now our foci always are opening or along the transverse axis, which in this case is along X. So we're going to have from our center negative 2 plus or minus square root 29, comma 3. And that is our foci. I mean, I might want that to the nearest tenth, but that's where they are. All right. Because all of those things, vertices and foci and asymptotes, all depend upon where our center is. So this next one, we actually won't craft this. We're going to answer all those questions. So let's answer the center. What's the center? Negative 4, 3. And good job not falling for the trap there. Okay, so there's our center. And now let's say where it opens. Which way does it open?
It opens up and down.
Up and down because the y is the positive thing. Okay, that means my transverse axis is x equals negative 4, and my conjugate axis is y equals 3. That's going to leave now finding the asymptotes. So let's get our slope. What's our slope?
Our slope is square root 10 over square root 8.
Yep. The square root of whatever is under y over the square root of whatever is under x. Now hopefully you see that we could simplify that. Okay, it is a weird slope. You're not going to be able to count that very well. So you would get a decimal to count it if you were actually graphing it. So the equation of our asymptotes is y minus y1, so that's y minus 3. Do you notice that's exactly whatever's here? Okay. Equals m, we just found our m, root 5 over 2, and then x plus 4. So there, those are our asymptotes. Now our foci. So we need our focal length. Our focal length is c equals square root a squared plus b squared. So c equals root 18, which simplifies to 3 root 2. Now, since we opened along y, so we opened up and down, our foci are at negative 4, comma 3 plus or minus 3 root 2. And my vertices are negative 4, 3 plus or minus root 10. All right, that is all for today.